Okay, let's start. Hi, everyone. Welcome here to this amazing Saturday morning at COP26 at the Strathclyde Student Union. My name is Martin Weinstein. I'm from the Open Earth Foundation, a 501c3 nonprofit based in California. We've had the privilege to co-convene the Climate Action Data 2.0 working group alongside the Data Driven Environment Lab and one of the most important climate data networks out there called CAMDA, which was launched by the UNFCCC and Climate Works Foundation, in many ways to co-convene the broad climate data network in support, among other things, to the Global Climate Action Portal hosted by the UNFCCC. 4 months ago, we, in light of the advances in technology and data management and data handling, we decided to launch a new working group to bring that network together called the Climate Action Data 2.0. And today we will be discussing some of the core principles for a new declaration that we want to put out in COP26 for collaboration and collective participation, but very hands-on approach for the community, and we don't need to live transcript, right?
You don't think so? I mean, I thought it was 2.0.
Okay. And what we'll do in today's session is share a couple of background context and work that might help us think through how to tackle that declaration. For context, in COP25, the CAMDA community launched a specific declaration on robust data collection and data tracking. So these declarations are a sign of a strong commitment of the community, particularly community in support of the UNFCCC process. And this year, it's taking it one step further. If COP25 was a declaration about what we need to do, this declaration in COP26 about how. The why is the most important one, and it is around being able to have robust climate data to improve accountability of pledges, improve detection on the best opportunities for action, and also in support of the negotiations, but ultimately to make sure that we've got such a short window on the climate action front that if we can't count and track it, it's become really hard to manage it, and we might go into an overshoot mode, as in we thought we were hitting a target and we didn't, and we over emitted. So with that, I would like to give just a couple of quick brief introductions. Yesterday, we talked introducing the topic of the importance of an independent process. The formal process relates to countries and the UNFCCC. Whereas I was just sharing recently that a very important case for a robust independent climate data working group, in some sense, was in the lead up to the Paris Agreement. Networks, for example, like Climate Action Tracker, produced a very good assessment of how INDCs, the intended nationally determined contribution, were actually meeting or unmeeting the targets that the Paris Agreement needed to achieve. And therefore, without that independent climate data network, it would have been really, really hard to put the right level of pressure and ratcheting of ambition. And this is just the beginning. We will be doing, countries will submit their inventories every year, but more than anything, we're transitioning towards a global stocktake. And the global stocktake is the process by which the countries come together, submit their inventories, the Secretariat reviews that, and we figure out what was said, what was done, and what is needed to meet the 1.5 efforts. But the the level of data fragmentation and the delay that there's been so far historically on putting together inventories. For most countries, inventories are, if they're a year old, that's an amazing inventory. Most of the time they're 2 or more. So being able to bring the level of insight closer to the level of action and policy, we'd be able to navigate the next years of stocktake a lot better. And so we feel that the subnational and the non-state actor community has a very important role to play to perhaps also ease the work of countries in putting together their inventory. But this has to be an independent process. So we introduce these topics and the concept of nested accounting as something that's more jurisdictionally based, where data, but more than anything, the data assets, or as it says here, data unit, is able to have a record of where it was created, where it happened, where it was retired or consumed. If it's talking about a product, and we'll soon show a video of the ability to use cutting edge technology to track the embedded carbon in products across the supply chain, but also the data in context, in jurisdictional and policy context, which means that if it's an action that's taken by a corporation in a part of the supply chain inside a city, then it's relevant towards the city, and it's relevant to where the city is in a provincial or state jurisdiction, and rolling up to the country, and furthermore rolling up to the planet. We also showed this slide, which puts the role of inventories in context, and we've had over the last couple of years new methodologies or techniques proposed for the creation of inventories. The standard way of doing it is through sectorial data compilation and aggregation through the IPCC methodology. This is the legacy or the status quo of how we tackle it. The description of nested accounting that I described looks at an action and a data point in the context of different spatial scales, city, state, country, and furthermore, we have now more and more tools for remote inventory creation, which are based on the interplay between satellite data and the use of machine learning to infer the emissions on the ground. If we put these into a scale, the one on the left is by far the faster. The one on the right has proven to be somewhat slower. And we think that a nested accounting would be roughly in the middle. The point here is that no one approach competes with the other. We need to find a way of create inventory comparison and harmonization towards being able to create an independent global assessment. So that's just to introduce the topic and something that's been relevant to the CAMDA community and part of the discussions in the Climate Action Data 2.0. In fact, we have here the primary site where the working group is being managed in climatedata.network. And we hosted a visioning exercise to map out how the 3 work streams that the Climate Action Data 2.0 working group has, which is data harmonization, digital infrastructure, and policy, and how they all interplay towards that vision of perhaps having by 2030, which would be right after the second global stocktake, a stocktake that would be almost in real time, that we would have a level of granularity towards understanding where action is more needed, where things are working, who needs to ratchet their emission more, how are subnational and non-state actors actually helping and contributing to the achievement of NDCs, so that we move towards a very clear positive feedback loop, as in the national level supports the ecosystem for subnationals and non-state actors to achieve their own pledges, and that also helps to achieve the pledge of the national. And we've had some very interesting insight, but perhaps the most important one is the power of collaboration to bring in all the different pieces needed within that puzzle. So the declaration that the Camden community and the Climate Action Data 2.0 network will be presenting today is around that, that level of statement. With that, I'm going to kick off with a video that the Open Earth Foundation has been doing. For a couple of years, we've been working on the research of how do we think about nested accounting, and our role as a nonprofit is not just to think and theorize these solutions, but really to deploy them in technological tools that can also serve as reference implementations of what is needed from a technological and data point. Now that is a little bit convoluted, but what it means is if the technology space is not really properly communicating with the supranational space or the subnational actor, we need to be able to come in and provide tools that help navigate how these need to connect. And this is done in a purely open source and the development of digital public goods. So that's been the work in what's called the Open Climate Initiative. And I'll show a prototype of this recently. But we've also decided that creating these tools are important. It's almost just as important to deploy it with real on-the-ground actors. So around earlier this year, after a couple of years of discussion, we partnered with the government of British Columbia and Canada to test some of these practices. And I would like to show you a video that the BC government put together about the work that they've been doing and the work that that has operated with the Open Earth Foundation. And you will also notice in the context of the video, the mentioning of the United Nations Climate Change Global Innovation Hub. And that is because also the Open Earth Foundation has had the privilege to partner with the UNFCCC to design, think, and launch the Global Innovation Hub, conceived as also a digital network and a platform to bring in a good matching and enablement of climate solution supply and demand, particularly with a focus on cities. So what we'll show here as an example of a consumption-based GHG accounting, as in we're able to track supply chain from its origin to where a product is consumed, is relevant also to the design and the development of the Global Innovation Hub. Before I start the video, any questions or any remarks? Great.
Hi, I'm Bruce Ralston, Minister of Energy, Mines, and Low Carbon Aviation, British Columbia, Canada's westernmost province. Here in British Columbia, we're blessed with abundant natural resources, including gold and copper deposits throughout. BC is well positioned for the transition to a low carbon economy as we maintain our high environmental, social, governance standards. Our mining sector with some of the cleanest operations in the world, due in part to our province's clean, renewable hydroelectricity at the high level of industry innovation. This industry remains the largest private sector employer of Indigenous peoples in Canada, providing economic opportunities for rural and remote communities while advancing reconciliation. BC's mining sector provides the responsibly sourced minerals and metals needed for the growth of emerging technologies such as electric cars, wind turbines, and the transit systems the world will need to fight climate change. We're a critical part of the global supply chain, and we're constantly improving the leading ESG. That's why we're working to create a system which our BC mines can easily share their emissions data with investors and buyers. This will provide BC mines and exploration companies with a significant advantage in terms of branding our metals and minerals to global ESG investors. I'm pleased to share with you the work we have done here in British Columbia on the Mines Digital Trust ecosystem.
My name is Nate Newman Blake, and I'm an Assistant Deputy Minister of the Ministry of Energy, Mines, Low Carbon Innovation in the province of BC, Canada. I'm excited to be introducing this interoperability demonstration of BC's Mines Digital Trust ecosystem. In this demonstration, we are showcasing one particular use case that will be of interest to the COP26 audience, namely how with a few mouse clicks and keystrokes, a a government-issued operating permit and carbon emissions data from a mine on the Pacific coast of Canada can scale into the global carbon accounting platform being pioneered by the Open Earth Foundation through the use of open source technology called Hyperledger Area. We've chosen this technology as the means for information sharing because it's highly transparent, secure, tamper-proof, and immutable. In BC, we have strong climate action. BC implemented the first carbon tax, and we've committed to 8% reduction in 2007 GHG emissions by 2030. BC is the first province in Canada to set GHG emission reduction targets and mandatory reporting from major sectors of the provincial economy, which has resulted in government-held data about the emissions performance of our industry. In the following demonstration, you'll first see the province making a secure connection with the IBM digital wallet of Copper Mountain Mine located in Princeton, BC. This will follow with the issuance of a permit, GHG emissions data. This includes carbon intensity, Scope 1 and Scope 2 data. This is the start of the supply chain tracing journey. The information can be amended, say if a permit is revoked or invalidated, but a transaction history will always remain in the system, thus validating the origin of the data. In this demo, the government of British Columbia will issue an emissions profile credential from the digital wallet on the left to Copper Mountain Mine's wallet on the right. First, Copper Mountain Mine and the government of British Columbia need to make a secure connection between their digital wallets. Copper Mountain Mine then asks the government of British Columbia to issue them 2020 emissions profile credential for their facility. The government of BC sees that the 2020 emissions profile credential is being asked for, and they are ready to issue it. On the Secure Connections page, they click on Copper Mountain Mine. They start the credential issuing process and select the credential to be issued. Upon clicking Submit, the data contents are checked for errors and the emissions profile credential is issued to Copper Mountain Mine. Copper Mountain Mine sees the notification, clicks on the credential to review its details, then accepts it. It now shows the new credential in their wallet. At any time now, they can click on it to inspect the details and add a label for it. With this credential, Copper Mountain Mine now has the ability to provide proof upon request to its other secure connections. The next step is the linkage between Copper Mountain Mine's IBM digital wallet and the Open Earth integrated carbon data accounting system, which is called Open Climate. Because of the tamper-proof cryptography of the credential, Open Earth does not need to check back with the government of BC about the trustworthiness of the information.
This screen shows the login process. The Open Climate portal is asking the authorized representative of Copper Mountain Mine to provide their login credential. It's being done using a QR code because it's using the same digital trust network and the BC government is the trust provider. The user from Copper Mountain Mine can scan the credential and log into the Open Climate system. Copper Mountain Mine presents proof showing that the BC government has issued their emissions profile. Upon logging in, the system will detect the information that comes with the Copper Mountain Mine's credential, namely the GHG emissions report, where the mine is registered and from which facility it comes from. The Copper Mountain Mine user is asked by the Open Climate system to confirm the import of the climate credential. The Copper Mountain Mine user gets to decide whether their data can be stored, used, and disclosed in Open Earth's platform. Once the Copper Mountain Mine user has confirmed they want to import their data into the Open Earth network, they are taken to the Open Climate portal launch page. From there, they can go to the Copper Mountain Mine profile, which shows the specific mine for which they have submitted information and the emissions credential itself. The Open Climate system allows users to understand how the actions they take to reduce emissions have an impact on a regional, national, and global level. This screen shows Copper Mountain Mine's emissions inventory in map view. This screen shows Copper Mountain Mine's emissions inventory, as well as illustrative trades and transfers, and how these scale up to a global emissions calculation. In the credential box, on the bottom right of the screen, you'll see the emissions credentials issued by the government of BC, which have been transferred via Copper Mountain Mine's IBM digital wallet, and are now nested into a regional, national, and global carbon accounting system.
What makes the mine's digital trust ecosystem unique is our commitment to interoperability, traceability, and open source technology. In essence, We see this digital ecosystem as public good. The technology will enable our business community, auditors, third-party verifiers to leverage government health regulatory data and contribute credentials to meet the global market's demand for transparency and trust. In the coming year, we will continue to advance the interoperability of the Mines Digital Trust so companies can choose whichever one solution they wish and still be able to participate in the digital trust ecosystem. At the other end, consumers and investors can determine what credentials are important and who they trust to issue them. And finally, we're excited to continue to contribute to the ambitious work of the Open Earth Foundation and the UN Global Innovation Hub in exploring how to understand and transparently track the carbon footprint of our consumer products, company commitments, and jurisdictional reporting. Please join us on that journey.
Great. Hopefully that gives some illustration of a couple of things that I would like to point out why they might be particularly relevant to what we were discussing before, the Climate Action Data 2.0, the declaration. What we saw just now, just to put it into more context, is this thesis that the way for subnationals and non-state actors to indirectly participate in the Paris Agreement is through geolocalizing their actions, but eventually could help support the creation of national inventories. What the platform shows is the use of these dashboard views. We could also go into a map view for all registered sites in Canada, but we can change into from a country level. So all the borders that are there are defined cryptographically so that anything that's contained within that jurisdiction rolls up to the national inventory, the independent national inventory, as it would be sort of bootstrapped or created from.
Can you explain what you mean by the borders are determined cryptographically?
Yes. So we talked about a credential, right? A credential is like a driver's license that a government issues. So what it means is that the digital network, so one of the key things that was showed in the video that is relevant to collaboration in climate data is digital trust. So how do we have digital trust, right? So in this case, how do we trust that the data is part of the country and it's being tracked properly? Well, a credential is issued to the spatial sector, right? So that means that the jurisdiction is not just what you normally see in Google, which is, okay, it's right. It's a boundary, but it's issuing to the boundary and the properties that every phone or anything that's connected to the internet actually knows its GPS location. It says, I'm inside this boundary, and this boundary has a credential that relates to the country of Canada and the climate tracking process of the country of Canada. The same thing happens if we go into the BC side. So we didn't talk deep into how many credentials are involved, but the use of verifiable credentials is part of this digital trust network. In the logic of digital trust through decentralized identifiers and verifiable credentials, which is a specific blockchain-based application, there's always an issuer of a credential, a holder of a credential, and the capacity for a third party to verify it. Now, the verifier, so again, if we look at the provincial side, that map view of those contours also would have a credential because someone can then verify the information that's within those boundaries without having access to the full data. And we mentioned this yesterday, perhaps one of the most important technological breakthroughs we've seen for the inclusion of non-state actors into climate data reporting is enable transparency of the data alongside privacy, trusted transparency. That is allowed when a verifier verifies a credential that's held by, for example, a company. They can trust the data that's presented without knowing the source information. So if we go into the Copper Mine site, this is also in map view, we can look at the, well, we can add BC and go to, here. Where are the details here? Right here. Okay, cool. So we can see the details of how the data is being transferred from different parties, as who sourced the data, who verified the data, and how that data gets added towards a final number. So it's kind of, this is showing essentially the data trail and the chain of custody of that data. Now, what is, even though this is one type of implementation, I think at the heart of it, if we think back at some of the diagrams that I showed, here, to be able to do a proper assessment, what we need to do is trust the data, right? We have specific protocols in the internet to be able to trust each other through the internet protocol or the IP addresses. This is very analogous to that. And we see it as the backbone for the creation of a climate internet, which is what's described here. Part of it is a network of stakeholders, and the other part is essentially the importance of a digital trust network when it comes to data. Who said what's the information to provide that, and how I can verify it. If we don't have that backbone, it would be probably impossible to bring all this information together for local and global insight and transforming that insight into action. I think I'll pause there unless there's specific questions. I thought it was a really good question. Anything that was presented that was not clear. What we thought was particularly relevant is this interplay between the subnational government and the private sector. There's probably one last thing to mention from the video that's relevant is accounting, even for the Paris Agreement, has different aspects to it. And one of it is what happens when carbon, either emissions embedded into products or carbon from mitigation outcomes, are transferred internationally. So this is perhaps at the heart of the Paris Agreement Article 6. And what we baked into this platform is the ability to create automatic corresponding adjustments. What that means is that if a copper bundle gets shipped out of BC and sold into a company, let's say in Japan or in Korea, that gets registered as a trade and a transfer of those emissions, and the receiving country can accept that carbon and take responsibility for it. Once that happens, you can imagine that that carbon that was registered upstream in BC needs to be reduced from the BC inventory and added to the Korean or Japanese inventory. Both countries need to agree that that transfer is happening, but that trade and transfer might be happening at the subnational or the non-state actor level. So these level of agreements are key on how we negotiate the level of international play. But it's key that we are able to think about, well, for that to happen, what would be the technology and the digital trust network to enable that? So this is one of the key things that we wanted to showcase and research because it particularly pertains to how we negotiate things in this COP26, defining the details of Article 6. I think that was the sort of like last key point. So open for questions. Yes,
So
Professor Shu.
this might be a provocative question, but I mean, I'm looking at this case of the BC mines and it's pretty incredible. And then the example that you just talked about between BC and South Korea, it seems like it's still operating on a very small scale.
Yeah.
So do you think for this to actually work, you have to have full participation? Or do you imagine like a world, and we talk a lot about the idea of interoperability between legacy systems, existing frameworks, and then this future climate change internet. But do you think we need to have like 100% universal participation for it to actually truly work? Or is there a way where we can still piecemeal and have these different systems and still be able to get to the end goal of being able to track all of these emissions and actions?
Yeah, I think that's a very important question. My quick answer would be the latter, right? If we're like, oh, we can't really work on climate until we do 100% of the network, like we'd be burned by then. So, and also that leads to, I guess like changing tabs here is not that comfortable. Why these are complementary, right? So whatever is not picked up by the nested approach could be picked up by the satellite imagery, and also counterpart by the country level. What is relevant to the middle part is that it allows the policy to come into play. Satellite as well as a way of verifying something, but the middle part is what really shows a government that has some form of policy and a private sector actor to actually be related around a level of regulation. In fact, what we showed was digital implementation of a regulation. So the point is that this has value in and of itself, and it doesn't require 100% adoption. That being said, to create adoption, rather than saying, here's the verifiable credentials of Hyperledger Aries designed by OpenEarth, et cetera, it would be really hard to create mass adoption around that way. It's more like, this is the architecture. These are the standards that we, through pilots and testing, show that works and would enable that to scale. So we always try to think about pilots as a fractal that has all the components so that we can test them for scale, and that let everyone follow those standards and those protocols to build their own digital trust network. In fact, we might be launching a pilot next year with a city in Korea and implement this similar approach, but with a totally different technology, but following the same standards. So then what we do there is that show interoperability around digital trust networks that might be built in a different way, but because they follow similar standards, they can actually trust each other. So that level of technological heterogeneity is key, because no one wants to have a technology be shoved down their throat in some sense. That is a very important piece for adoption to happen. And a key part, I think, also of adoption to happen is the benefit, the win-win dynamics. It needs to benefit the government or the public sector because they're able to roll out a policy, implement and operate it, and check through it in a much less frictionless way. As in, like, I don't have to audit a company and I have to go out and police everyone, right? If I'm already able to trust the data, the cost of rolling up a policy is lower. And the feedback that I get on the implementation of the policy can help go back into the design of the policy. And for the private sector, that normally, when they get some form of regulation around disclosure of something, the knee-jerk reaction is like, no, I don't want to do that. I don't want to fill another form. And reporting, you've always discussed reporting fatigue, right? So how do we show that we remove a level of fatigueness because the data is kind of integrated, but also we bake into it the ability to create and roll out incentive mechanisms. As in, like, if you're pledging as a subnational or a non-state actor, and your pledge is aligned with a science-based target initiative, aligned with the Paris Agreement, actually help the country and the subnational meet its pledges, then and you're actually able to prove that, then the country might decide, or the subnational, to give an incentive, or even the investors and the consumers. And furthermore, that might lead to access to financial lines. So how do we find a way of integrating all this data so that you don't have multiple different sections? Like, okay, we have one climate data system for reporting to the government, one to report to the buyer, and one different one to report to the investor. It should be one, but everyone has access to with their different lens and perspective of what the data they need, right? The investor might not care about the embedded carbon. They might care about the environmental practices and the overall information about the company. The buyer might just want to know what's the embedded carbon, and the government might want to know what's the scope 1 emissions, for example. Great question. Any more? in terms of thinking through principles for a declaration, I think that already what we've laid out here, some of the things that we've discussed are embedded there. So when we're describing in terms of digital trust, we consider it as infrastructure, right? We also talked about digitally automated data in the global south. So how do we make this accessible for more developing countries that also have a harder time putting together their inventory? The nested accounting is more on the jurisdictional base. And when we talk about standards, it's the standards so that no matter how everyone does their implementation, these things can interoperate. And also how all of this enables policy, but policy that helps enable this. So there needs to be a kind of a dynamic process. And the ability to create adoption and interoperability requires that level of collaboration, requires that level of aggregation of the existing data. And let's start looking at leveling playing field. What's all the data we have and who put it together and what's the trustworthiness that we have of the data, and then start building from there. That requires a lot of collaboration. Yes.
Yeah, that was my question on your last point. So can you walk us through the process of how you work with BC to take the data that they already had and then integrate it with the system that you built? Because I'm thinking about a lot of the data that we work with in the Canada community, and this is amazing, but I'm thinking about how we actually implement this right away for the stock take, and I'm not sure if we can get there. But I mean, yeah, so if you could walk us through, like, did they give you data in spreadsheets? What kinds of data did they give you? And
Yeah.
how did you transition it into this model?
Yeah, it's the key question and a key part of what I would say also the infrastructure. So this is a first showing of the pilot. We're in the I would say early stage, and I would also clarify that what we're doing from the Openness Foundation and the Open Climate Project needs to go at a different pace than the government side. So that's very clear and transparent. We need to take it to a little bit more of a next level, but we also have to respect the comfort that they have in rolling things out because they're totally trying something new. And why do I mention that is because ideally, and this is how we've been designing the infrastructure, how the way you source the data comes directly through sensors. And so it's not self-reported. And that also can verify with another important agent, which is the satellite data, right? So this is where these two approaches can connect. So a company might say, hey, here are my sensors. And that might be a sensor of electricity coming to the site, fuel level of some form of furnace, so you can prove how much fuel you're consuming, CO2 sensors in the output of a furnace. All those sensors are very relevant to capture that upstream data. If we go even further upstream, and the other sensors are weight scales in the mining sector. So how much actual mass you're moving. Being able to implement that is our goal. We haven't integrated that level of robustness because it's an early stage and we wanted to respect the speed in which the government and the private sector wanted to move, but we built that into the system. So for the pilot that we just showed is through self-reported data that so far for the government is enough. However, if you see that is who audits that. So some are self-reported and the reality of today's climate data ecosystem is that probably 90% is self-reported. But then how do we deal with auditors, right? So most companies that present an annual report bring in some form of an auditor. So a participant in this pilot is, for example, PwC, PricewaterhouseCoopers, but other auditors that are, of course, out there working on this is KPMG, Ernst & Young, et cetera, Deloitte. So they play an important role. Do I trust your auditor, right? And it's kind of like when the government has to process taxes, do they also trust the CPA, the Certified Public Accountant? And it's a similar logic to it. So for now, it has the trust of the auditor. We want to move into, fine, the auditor is great, but I want to also trust the sensor. And if I can trust the sensor, I also want to make sure that I can trust the satellite, right? So moving into that level of robustness is the goal. I think that's where you're alluding to, right?
Yeah, and I mean, I think that this is an important point too. And in the panel yesterday, the interaction between Mayor Suarez and ACOM, to me, it's just how they talked about the interplay of, okay, they had this tool, they had this data that was self-reported, and then they used the EIE data, and then Nicole from Google was also showing the complementarity and the relationship between the two data sources. So I think the answer is that the self-reported data is not meaningless. It's actually useful on an organic basis because they were using it very much as ground truth data and to be able to understand the ranges of uncertainty. So I think we're not saying that we have to abandon self-reported data or that it's all flawed and inherently bad and not trustworthy. I think in the initial phases, especially as we're transitioning to this next generation approach, we have to really use that because it's all we have right now. I mean, really. And so I'm thinking about like some of the studies that we're finishing up, which are using the self-reported data as training data. So we're combining the satellite inputs and using the self-reported data. And we know and we can evaluate the flaws in that, but using that as important training data to then train the algorithms. And so then in our partnership with Google, we're going to be then taking their EX. So having that initial self-reported data, we know the relationship with these other inputs, and then that helps the algorithms learn the strengths and the weaknesses of both data sets.
Yep, that's such a great point, and very relevant also to show the importance in terms of collaboration rather than competition. This is not a competition of methodologies or approaches. This is a complementarity of methodologies and approaches. And that's why I put this slide again, right? Because it's not saying it's one versus the other. It's around the importance of harmonization that you always bring up.
Yeah.
Dr. Schlitz.
Yeah, maybe also just to reiterate that I think that decentralized trust web that you have a lot of different sensors, right? Because you also don't want to be depend on one single source of truth. Even if it's like satellite data or like a sensor, every source can be corrupted in a sense. So you want to have as many data points as possible and distributed as possible to maximize the trust and then triangulate data. And the self-reported data can also be important because the sensor might be off. So you can just like flag also where are the different data sources disagreeing and where should the human actually maybe come in or what should be reviewed. So it's not only that we want to just automate everything and just have everything very efficient, but it is about like kind of identifying and harmonizing a lot of different sources and creating interoperability.
Exactly. And then I think if you have enough pilots, I think this is the other part of the answer. If we have enough pilots and companies or subnationals that are willing to actually contribute data and open up their systems, then we can use that as training data to then estimate and predict emissions from global south actors. Like the Damia Cement, how they said, we're going to help climate trace by opening up all of our facility level data. If we got more companies and subnational actors to do that and participate, then I think you're right. We don't need to have 100% participation because if we can get the algorithms to a certain level where we can actually predict with a reasonable margin of confidence what's going on in the emissions of other places. And so, I mean, like just looking towards the declaration, I mean, that's maybe one of the principles that we should look for, right? Even just having companies just open up data and contribute to the climate internet, that could just be a start.
Right. And it's great to decant a lot of these into things that can be baked into the declaration. I think key underlying point here is 20 years ago, this level of data redundancy would not be as feasible, but I don't have a diagram for it, but the cost of data acquisition has gone down significantly. The cost of data processing has gone down significantly. And so we want data redundancy because we want to compare them together. We want them to cross-learn from each other. And the other interplay that you bring in is that when one company in one sector opens up their system to a certain level, it improves the ability for the network to derive the other companies in the sector. And why is that relevant is because when a company is doing things well, and they want to do things well, and they want to prove that their products are low carbon, they're also interested in showing that their competitors are not doing things well. So it actually brings them in a very good positive competition to say, hey, we're able to measure the carbon and climate performance of the companies, the carbon and climate performance of the products, so that the consumers make better informed decisions, and the investors make better informed decisions. So actually, for a company that steps in, actually helps the whole bring in transparency to the entire sector, or at least that would be the idea. Yep.
And maybe also just on the machine learning or artificial intelligence component, the more data we get in, the more accurate the predictions get. And I think also predictions are really important because we don't only just want to make exposed assessment of like what has been done in the past, but that we can predict like if we use these policies and if things are going as planned, like this is the roadmap, this is the trajectory of emissions. So training algorithms in the way that they can just on an ongoing basis take the data in and then predict also the next step and give feedback on policy action, for example. I think that's a key point as well, but that requires a database or a data layer that is robust enough and provides sufficient information for that.
Yeah, exactly.
So perhaps it's a good segue to go into the declaration, and I'd like to invite my colleague Marco Schletz to take the floor and continue the next of the session, since I think and Angel Shu as
Oh,
well.
no, I'm just kidding.
No, you come into the panel.
Yeah, so we have like maybe 2-3 minutes.
Okay, let's stop share and pause recording.
Yeah.